Hello everyone. In this video, I'll explain about three-dimensional geometry of class 12. So this chapter is all about three-dimensional geometry of straight lines. So let's know about straight lines first. Straight line is nothing but it is a set of all points that extend infinitely in opposite directions. See, you can see the geometrical representation of straight line here. All the five are different straight lines. Now these are all points. Those points extend infinitely in opposite directions or in both directions. Then the collection of all those points, when joined, you will get a straight line. So this is what the geometrical definition of a straight line. Now, to locate any point either in space or plane anywhere, you need a frame of reference. So if this is a point in space, to locate this point in space, where exactly the point is situated, we need a frame of reference. So the frame of reference in space is taken as the coordinate system, Cartesian coordinate system with the three axes, because three dimensional means there are three dimensions like length, breadth, and height. Two dimensional is just length and breadth, only two dimensions. In that case, we have two axes, x axis and y axis. So now the point can be anywhere in space. If you want to locate that point in space, we need a frame of reference, and that frame of reference is nothing but we use a Cartesian coordinate system. So in the case of three-dimensional geometry, there are three axes. One is x-axis, y-axis, and z-axis, and the point is denoted using the coordinates x comma y comma z. To locate a point in space, we have to drop a perpendicular from the point to the xy plane, then again drop a perpendicular to the x-axis, then again drop a perpendicular from the foot of perpendicular to y-axis. So this gives you the x coordinate of the point, this is the y coordinate of the point, this is y coordinate of the point, and this gives you the z coordinate of the point. Hence the point is uniquely determined as ordered triplet x comma y comma z. Similarly, when you have different lines in space, so we have to get the direction of that line, because a line can have either the forward direction or backward direction, or two out of two directions, the given direction and its opposite direction. We have to check in which direction the given line is oriented in space. So we need frame of reference. The same frame of reference will work here, the coordinate systems. So to get the direction of any line in space, we have the concept of direction cosines. So why we need to find direction cosines of a line? Because we need to find out the direction of line in space with respect to the coordinate axis. The frame of reference here is the three-dimensional frame of reference, which is having x-axis, y-axis, and z-axis. Now you have to consider any line which is in space. To find its direction cosines, first we need direction angles. So direction angles are nothing but the angle made by the line with respect to the positive direction of x-axis, y-axis, and z-axis. Now if you consider this line, you can get just here angle made with the with the z axis by the line, by the given line. But when if you need the angle made by the line with x and y axis, what you should do is you have to draw a line parallel to the given line which passes through the origin. So this is the condition to define direction angle. The line should pass through the origin. If it doesn't pass through the origin, you have to draw a line which is parallel to the given line and passing through the origin. Now, the angle made by this line with respect to the positive direction of x-axis is alpha, with the positive direction of y-axis is beta, with the positive direction of z-axis as a gamma. Then these angles alpha, beta, gamma are called as direction angles of a line. That will specify what is the direction of the given line, where exactly it is located in space. So the cosine values of the direction angles, that is cos alpha, cos beta, and cos gamma, are called as direction cosines. They are denoted as L, M, N respectively. L equal to cos alpha, M equal to cos beta, and N equal to cos gamma. We take direction cosines, we don't take direction sines, we don't take direction tangents. We are specifically here defining direction cosines because we use the cos function. The cos function is used here because we have the definition of cos as adjacent divided by hypotenuse. Okay, this is adjacent divided by hypotenuse. I will tell you why only the function cos is used here. To know that you have another set of direction angles as well. So that is, if alpha is the angle made by the line with the positive direction of x-axis, the same line makes another angle with the positive direction of x-axis, which is pi minus alpha, because the angle along on a straight line is 180 degrees. So if this is alpha, this is pi minus alpha. That is also an angle made by the line with positive direction of x-axis. Therefore, there are two sets of direction angles, alpha, beta, gamma, and pi minus alpha, pi minus beta, pi minus gamma. These are also direction angles of the given line. So when pi minus alpha, pi minus beta, pi minus gamma are the direction angles, so in that case, cos of pi minus alpha, this is minus cos alpha, because in the second quadrant cos is negative. So you will get minus L, minus M, minus N. These are another set of direction cosines of the same line. That means positive L, M, N gives you the direction this way and the negative LMN in the opposite direction. So there are kind of two set of direction cosines for a given line based on is it in the forward direction or backward direction. Here I am, for this line I am telling forward and backward. Therefore, here we are using, that's why we are using cos function, because when you use direction signs of a line, what happens, you see, sine of pi minus alpha, that is equal to sine alpha, because in the second quadrant sine is positive. So you don't have two different set of direction cosines here. For both the directions you will get lmn only, because L is positive, M is positive, N is positive in the second quadrant also. In the first quadrant also they will come as positive only. So you don't have a unique set of direction cosine, direction signs for the given line. That's why we don't use that sine function. We specifically use a cosine function. That's why they are called as direction cosines of a line. So now what happens is, instead of measuring the angles alpha, beta, gamma, now we have converted that value into some real number, L, M, N. So L, M, N are real numbers. So whenever you are referring the direction of that line, you can refer to the values of L, M, N. Every time, instead of saying it makes an angle alpha, it makes an angle beta, it makes an angle gamma with z axis, instead of that, I can say it algebraically as, in terms of direction cosines of a line are L, M, N. That makes your work easier, because this is geometry. Measuring the angle and writing those angles alpha, beta, gamma, that is purely geometrical. We are giving some algebraic touch to the geometry to make the study simpler. So that's what we call it as analytical geometry. Geometry studied with the help of algebra is called as analytical geometry. That's what we are doing here. Alpha, beta, gamma, all these measurement that comes under geometry. Now we are converting the geometrical values into some real numbers, and we are making use of those real numbers to get the direction of a lines. So that they are called as direction cosines of a line. Now there is a relation between direction cosines of a line, that is L square plus M square plus N square equal to 1. This is the relation between the direction cosines of a line. So if you want to prove, let's see how the proof goes. Now this derivation is not there actually as per the new syllabus, but you should know the relation between the direction cosines. That is very important. I have considered a point in space here. The point in space is located using the ordered triplets x, y, z. Okay. So now this line OP, makes an angle of alpha with the positive x-axis, beta with the positive y-axis, and gamma with the positive z-axis. Now what you should do is you have to drop one perpendicular from the point to the x-axis. Then you will get a triangle OPM. This is right angle triangle. From the triangle OPM, cos alpha is equal to cos is adjacent by hypotenuse, OM by OP. OM is x coordinate of the point. You should know this. The dropping perpendicular from the point to the x axis gives you the length of this OM gives you the x coordinate. Then y coordinate, length of the perpendicular here. Then not length of the perpendicular. From the origin to the foot of the perpendicular. That length is nothing but the coordinates of the point. Cos alpha is x by r is nothing but the distance of a point from origin, which is the radius vector we are taking, x by r, so which gives you x equal to LR. Similarly, from the point P, you have to drop perpendicular to the y-axis. Then again cos beta is equal to, that gives you y equal to MR. From the triangle OPQ, cos gamma equal to, you will get z by r, which is z equal to NR. Then x square plus y square plus z square equal to, equate this. This value is equal to r square, which is equal to r square into this simplification, L square plus m square plus n square is equal to 1. This is the relation between, you have to just remember the relation between the direction cosines of a line, which is L square plus m square plus n square equal to 1. Now about direction ratios. The numbers which are proportional to the direction cosines of a line are called as direction ratios. You can name them as A, B, C. LMN are direction cosines. The numbers which are proportional to the direction ratio cosines are called as direction ratios. So A is proportional to L, any number which is multiple of B is proportional to M, C is proportional to N. So A equal to, the proportionality symbol is removed, and lambda L, B is lambda M, and C is lambda N. So we have, because they are of same line, so lambda is same here. L square plus m square plus n square equal to 1. Using that relation, L is A by lambda, so A square by lambda square plus B square by lambda square plus C square by lambda square equal to 1. So this comes out to be lambda square equal to A square plus B square plus C square, which is plus or minus square root of A square plus B square plus C square. So L is L equal to A by lambda. So A divided by square root of plus or minus A by root of A square plus B square plus C square, because lambda equal to L equal to A by lambda. So plus or minus A by lambda we got as this. Similarly, M equal to plus or minus B by square root of A square plus B square plus C square, and N equal to plus or minus C by square root of A square plus B square plus C square. So this is how we can obtain direction cosines when direction ratios of a line are given. So direction ratios is a more generalization. For example, when you get direction cosines of x-axis, so x-axis makes an angle of 0 with the x-axis. So it is cos of 0 is 1. Then with the y-axis 90, 0. These are the direction cosines of x-axis. Okay. Now direction ratios of x-axis are any multiples of direction, that is k 0 0. Okay, so this gives you any point on the x-axis. 100 is only the unit vector along the x-axis gives you, whereas k00 direction ratios gives any vector in the direction of x-axis with any magnitude. This gives you only unit magnitude. That is what direction cosine. That is the main difference between direction cosines and direction ratios. So with respect to any point in space, you can have a position vector. So with the help of that point in space, x comma y comma z, so these are the coordinates, that is x component, y component, and z component of the vector, position vector of that point. Then with the help of that, if you draw a line passing through that point and passing through the origin, then you can get its direction cosines. What are the angles made by the line with positive x, y, and z axis? You can calculate that. See here, a line can have infinitely many sets of direction ratios. That is, if A, B, C are direction ratios, then Ka, comma, Kb, comma, Kc, K not equal to 0, multiples of that with a constant value, is also a set of direction ratios for the given line. So there is no unique set of direction ratios, but a line has unique set of direction cosines. There are, like, if the angle made by the line with respect to positive direction of x, y, z axis, if that is constant, same, then it will give you only one set of direction cosines. If you, as per the components, if you write the vector form of that direction cosine, then you will always get a unit vector. Okay, 1 0 0. So because L square plus m square plus n square equal to 1, the magnitude of that vector, if you consider, then you will get always a unit vector direction cosines. In the case of direction ratios, it is more than the unit vector. You will get all other points as vectors, means all other points on the x-axis also as one of the direction ratios, if you are considering the x-axis. If direction cosines are same for any two lines, then that means the lines are parallel. So that is what specified here: 0 degree, 90 degree, 90 degree with the x-axis. L is 1, M is 0, N is 0. So k 0 0 are direction ratios of x-axis. You go on giving the value for k 2 0 0, another point on the x-axis 3 0 0, 4 0 0. So direction ratios will give you all possible points on the x-axis, whereas direction cosine will give you the unit vector on the x-axis, along the x-axis. That gives you the direction. Its job is to give you the direction, the orientation, or the location of that line with respect to the origin. Whereas direction ratios will give you all possible scaling of the unit vector. So if 100 is the unit vector, you can scale it along the x-axis, increase the length or decrease the length, that you will get in direction ratios. So that's what the significance of direction cosines and direction ratios. We need both. So in case if you have a set of A, B, C as direction ratios of a line, then you can write its vector components as AI cap plus BJ cap plus CK cap. This is always true. If you have direction cosines L, M, N, then its vector components Li cap plus Mj cap plus Nk cap. But this is always a unit vector. Whereas its direction is same as this, but it need not be a unit vector. So you can always have, this gives you the x component, B gives you the y component, C gives you the z component of the given vector. AI cap plus BJ cap plus CK cap, because every point has its position vector, which can be named like this. So a direction ratio refers to some point on the in the same direction as given by the direction cosines. Now finding direction cosines of a line joining 2 points. So I'll take 2 points in spaces P x1 y1 z1, q x2 y2 z2. There is a line passing through these 2 points. So you know that if you want to get the location or the direction of this line in space, you have to draw a line parallel to the given line passing to the origin. Now alpha is the angle made by the line with respect to positive x-axis, beta is with respect to positive y-axis, gamma like this is positive z-axis. So that can be marked here itself, because parallel angles must be same here with respect to positive z-axis. So then you have to draw perpendicular from the point P and Q to the xy plane. So that is R and S. From the point P, draw perpendicular to QS. That is foot of the perpendicular is N. Now, just to get the angle, if, as this angle is gamma, the angle PQN must be gamma. Okay, this way. The angle PQN must be gamma. So from the triangle cos gamma equal to Qn divided by PQ, Qn by PQ, adjacent by hypotenuse. So you will get Z2 minus Z1. Qn is nothing but the z1 coordinate here, z2 coordinate, this distance is z2 minus z1 divided by pq is distance between 2 points. Similarly, you will get y2 minus y1 by pq, z2 minus here x2 minus x1 by pq. Pq is distance between the 2 points. So using the distance formula. So you will have L equal to x2 minus x1 by pq. This is your cos alpha, cos gamma is this n, cos beta is m, cos gamma alpha is l. So these are the direction cosines of a line joining 2 points. Now direction ratios, one of the set of direction ratios can be given by numbers proportional to x2 minus x1 is proportional to L, because this numerator itself is proportional to x2 minus x1. This is proportional to y2 minus y1 as there is in the, that is in the numerator. So you will have direction ratios x2 minus x1, y2 minus y1 and z2 minus 1, z1. These are the direction ratios of the line. Let's solve some problems now. If a line makes angles 90 degree, that's alpha is 90 degree, beta is 135 degree and gamma is 45 degree, then find its direction cosines. So one way to locate the direction of a line is telling its direction angles. Algebra, this is in the language of geometry. Now I want to say the same thing in the language of algebra, where the line is located in space. That can be done through L equal to cos alpha, M equal to cos gamma, cos beta, N equal to cos gamma. So this cos 90 is 0, cos 135 is cos of 180 minus 45 degree. So that gives you minus 1 by root 2, because in the second quadrant cos is negative. Then cos 45 degree 1 by root 2. So I am giving you geometrically what I am saying here is I have a line which makes an angle of 90 with x axis, 135 with the y axis and 45 with the z axis. So the same thing I am telling in algebraic language as there is a line with the direction cosine 0, minus 1 by root 2, 1 by root 2. Both mean the same, but the way of telling is different. This is algebraically, this is geometrically. But every time you can't measure the angle and draw the line. It is impossible to draw a line in space using pen and paper, because pen and paper is two-dimensional. So in that case, the study is made easy just by getting its direction cosines. Now, find the direction cosines of a line which makes equal angles. That is alpha equal to beta equal to gamma, which is making equal angles with the coordinate axis. So this gives you L square. You have a relation L square plus M square plus N square equal to 1. Therefore, cos square alpha plus beta is also alpha only. Cos square beta plus cos square gamma is equal to, that is cos 3 times cos square alpha is equal to 1. Cos square alpha equal to 1 by 3. Cos alpha is equal to plus or minus 1 by root 3, or just 1 by root 3 also fine. Therefore, you have two set of direction cosine. Cos alpha is L, 1 by root 3, 1 by root 3, 1 by root 3, or minus 1 by root 3, minus 1 by root 3, the opposite direction. Similarly, the positive x-axis actually 1, 0, 0. The negative x-axis minus 1, 0, 0 direction cosines. Because negative x-axis means the angle made by the line with respect to positive x-axis becomes 180 degrees. So cos of 180 is minus 100. But we usually say direction cosines of x-axis as 100. Okay. So this will tell you that there is no line making an angle of 45 degree with the all the three coordinate axes, because in case if it makes angle of 45 degree with the all the three coordinate axes, then what happens? L becomes 1 by root 2, M becomes 1 by root 2, N becomes 1 by root 2. Okay, so this gives you L square plus M square plus N square is 3 by 2, which is not equal to 1. Therefore, you can never have a line which makes an angle of 45 degree with x-axis, 45 degree with y-axis and 45 degree z-axis. So it's not possible. So see, without drawing a line, without checking it using the geometrical way, we can sit here and we can check, is it possible to have It is not possible. If it makes equal angles with respect to the coordinate axis, then direction cosines must be 1 by root 3, 1 by root 3, 1 by root 3. There are no other possible ways. That is direction cosines of a line which makes equal angles with the coordinate axis. So direction angles are cos inverse of 1 by root 3. And alpha is cos inverse of 1 by root 3. Beta is also cos inverse of 1 by root 3. Gamma is also cos inverse of 1 by root 3. Only for that particular angle, you will have the direction cosines 1 by root 3, 1 by root 3, 1 by root 3 with the equal angle. So angle must be cos inverse of 1 by root 3. Not possible for any other angle. So that is the fact. Next, third question. If a line has direction ratios minus 18, 12, minus 4. So this is A, B, C. So you should find out square root of A square plus B square plus C square. You can check that it comes out to be 22. So you know that L equal to plus or minus A by root of A square plus B square plus C square. That is equal to plus or minus. Here you have minus 18 divided by 22. Do the simplification. M equal to 12 divided by 22. N equal to plus or minus also you can add minus 4 divided by 22. These are the direction cosines of a line whose direction ratios are given. Now, fourth question is show that these points are collinear. Collinear means they lie along the same line. So, I'll name the 3 points as A, B, C. First point, second point, third point. Now, first let us find out direction ratios of AB, then direction ratios of BC. This is A, this is B, and this is A. 2, 3, 4. Then minus 1, minus 2, 1. Then 5, 8, 7. This point A, this is B, and this is C. You can use either direction cosines or direction ratios. Direction ratios easier because just you have to find out x2 minus x1. So direction ratios of line AB, they are nothing but x2 minus x1. They are minus 3, minus 2, minus 3, minus 5, then 4, 1 minus 4, minus 3. Minus 1 minus 2 minus 2 minus 3, then 1 minus 4 is minus 3. Similarly, direction ratios of BC, next to 2 points, 5 plus 1 6, then 8 plus 2 10, then 7 minus 1 6. Now you can see that direction ratios are proportional. Either they are proportional or equal. In that case, we say that the two lines here collinear because B is a common point for both A, B and BC. So they should lie along the same line. Direction, one thing is direction ratios are proportional. The lines could be parallel, but here they are not parallel because B is a point which is common to both AB and BC. Therefore, the line 3 points must be along the same line. Next question, find the direction cosines. Here they are asking you to find direction cosines of a sides of a triangle whose vertices are 3, 5, minus 4, then minus 1, 1, 2, then minus 5, minus 5, minus 2. So in this case, first to find the direction cosines of side AB. So how to do that? x2 minus x1 by distance between AB, which gives you L. Then m equal to y2 minus y1 by AB, distance between the 2 points A and B. N is equal to Z2 minus Z1 by distance between the 2 points AB. Similarly, do it for BC. Divided by BC, you will get. For AC, it is divided by AC. This is how we solve problems related to direction cosines and direction ratios. Now is about equation of a line in space. Now, if you want to determine a line uniquely, there should be two conditions given. One is a point and a direction is given, or else 2 points are given. Only in that case you can draw a line uniquely. So suppose if I have given you only 1 point, then there are infinitely many lines passing through that point. So 1 point is not enough to draw a unique line. Unique means there is only one line passing through that point, not possible. But instead of that, a point and its direction is given. So this is the direction. In that case, I can draw a unique line or a point and the direction this way. In that case, I can draw a unique line. Or else, if 2 points are given, passing through those 2 points like this. So in that case, we can draw a line uniquely. So now the first case, only first case included equation of a line through given point and parallel to given vector. Parallel to given vector means direction is given and a point is given. So consider a line in space. This is a line in space which passes through the point A and it is in the direction as that of vector B. So I have to indicate the direction like this. Now consider any point P on the line, general point. Now join the points to the origin, you will get the position vector of the point. OA vector is the position vector of point A and OP vector is the position vector of the point P. I will name that as R vector, OA vector as small letter A vector, because you have to get the equation both in vector form and Cartesian form. Vector form means using that position vector of the points we are deriving an expression. Cartesian form means using the points coordinates of the points we are deriving an expression. So now you consider this vector AP. AP vector, you know that it is parallel to B vector, or AP vector and B vector are collinear. They are in the here same direction. So therefore one vector is a multiple of another. Collinear means we can always write AP vector as a multiple of another vector, or else B vector equal to some constant into A vector. That is also fine. So I am writing it AP vector equal to lambda into B vector. Now AP vector can also be written as position vector of the second point minus position vector of the first point with the help of position vector. That is OP vector minus OA vector equal to lambda into B vector. So OP is R vector, OA is A vector equal to lambda into B vector. So when you bring it to the other side, R vector equal to A vector plus lambda B vector. So where lambda is any scalar. So this gives you the position vector of any point on the line which is passing through a given point and parallel to the given direction is given by r vector equal to a vector plus lambda into b vector. So you should specify what is a vector, position vector of given point. B vector is the vector parallel to the given line. So if you want it in Cartesian form, then you have to name, instead of position vector, we have to name the points using the coordinates. The point, given point A is x1, y1, z1. General point is x, y, z. Now A, B, C, B direction ratios of a line. Okay, of this line direction ratios, we already studied about direction ratios. A, B, C, B direction ratios of a line. We are not taking here direction cosines because you know that direction cosine is a particular. It gives you only unit vector in the direction, whereas direction ratios will give you vector of any magnitude in the same direction. So like 1 0 0. Okay, this is the unit vector from the origin if you consider. Then direction cosines of x-axis 1 0 0. Direction ratios of x-axis 2 0 0, 3 0 0, 4 0 0, any infinitely many. So direction ratios gives you all possible vectors in the direction of x-axis. So that's why we are taking the generalized version of which A, B, C, B direction ratios of a line. So then B is parallel to the given line. Vector B is parallel to the given line. Therefore, two parallel vectors or two parallel lines will have the same direction ratios. So here what we will get is B vector is always also has the same direction ratios. So I am writing AI cap x component, B j cap y component plus C k cap z component. Substitute all these in equation 1. We will get xi cap plus yj cap plus zk cap equal to x1 I cap plus y1 j cap plus z1 k cap plus lambda into ai cap plus bj cap plus ck cap. So now rearrange this. Two vectors are equal if corresponding components are equal. X1 plus lambda a, y equal to y1 plus lambda b, z equal to z1 plus lambda c. So you will rearrange this. X minus x1 by a equal to lambda, y minus y1 by b equal to lambda, z minus z1 by c equal to lambda. So altogether, because they are equal to the same constant lambda, so I can equate all the three ratios. So usually this doesn't look like a typical equation. Typical equation in the 2D, how it looks, ax plus by plus c equal to 0. It has left hand side, it has right hand side. Okay. But here it doesn't look like that your typical equation. Then how come it is said as equation of a line? This is actually three ratios are equated. Okay, this is also an equation wherein three ratios are equated. This probably gives you the possible values for x coordinate, possible values for y coordinate, possible values for z coordinate to get that line. See, x equal to x1 plus lambda a. When you equate every ratios to lambda, what you will get is x equal to possible values of coordinate x, possible values of coordinate y, y1 plus lambda b, and possible values of z coordinate, z1 plus lambda c. So when you give different values for lambda, you will get different points on the given line. So that's why the equation looks like this. And even if you in case if you get 0 in the denominator, it doesn't mean that something by 0 becomes infinity. It is not that typical division and all. It is the representation of a line. Okay, representation of a line where three ratios are equated because they are equal to the same constant lambda. Now, for example, find the equation of line which passes through 1, 2, 3 and is parallel to the vector 3i cap plus 2j cap minus 2k cap. It is parallel to the given vector, so this is b vector. So, components of b vector are nothing but the direction ratios of that vector. So, direction ratios of that vector and the line are same because they are parallel. So you will have b vector equal to this, a vector equal to I cap plus 2j cap plus 3k cap because position vector of this point. Given point, one is its x component, two is its y component, j cap, three is its z component. So your general equation is r vector equal to a vector plus lambda b vector. Substitute lambda belongs to r, some scalar. If you want Cartesian form, x minus x1 by a. A is, see, components, parallel vector, 3, 2, minus 2. This is A, B, C. So 3, 2, minus 2 in this denominator. It passing through the point. So this point x1, y1, z1. So you will get x minus 1 by 3 equal to y minus 2 by 2 equal to z minus 3 by minus 2. This is the equation of a line which passes through a point and parallel to the given vector in Cartesian form. Now, after getting the equation, if you equate this to a constant lambda, then you will get its x coordinate as 3 lambda plus 1 cross multiply, y coordinate as 2 lambda plus 2, z coordinate as minus 2 lambda plus 3. The lambda is some scalar, some real number. So when you go on giving the value for lambda, that is lambda equal to 0, that's what I told. It's like a typical, it's not like a typical equation as you have a left hand side, right hand side. It gives you a relation between x coordinate, y coordinate and z coordinate of a point in terms of lambda. So when you put lambda equal to 0, x comma y comma z becomes 0, 1, 2, 3. That's a point on the line. Lambda equal to 1, so 4, 4 and it is 1. Another point on the same line. Lambda equal to minus 1, xyz becomes minus 2, 0, 5. So when you plot all the points in space, then join all those points, you will get that particular line. The equation of that line is given by x minus, as you said, x minus x1 is 1 divided by 3 equal to y minus 2 by 2 equal to z minus 3 by minus 2. Geometrically drawing this line this way and algebraically saying this line as using the equation of a line. Now, what's the formula to find angle between two lines in space? You consider two lines L1 and L2 in space. Then L1 is having direction ratios A1, B1, C1, L2 with direction ratios A2, B2, C2. Take any points P and Q on the line L1 and L2. Then, when you have direction ratios, you can write the vector OP vector as A1 I cap plus B1 J cap plus C1 K cap. That's the use of direction ratios, because two vectors and lines which are here coinciding, because on the same line I have taken the point, we should have the same direction ratios. So when it is vector, then the components of that vector are nothing but direction ratios of the line. Similarly, OQ vector equal to A2 I cap plus B2 J cap plus C2 K cap. Now, angle between L1 and L2 is same as angle between the two vectors OP vector and OQ vector. So, we have the formula to find angle between two vectors that we had in vectors chapter. So, cos theta is modulus of OP vector dot OQ vector by magnitude of OP vector into magnitude of OQ vector. This is dot product of two vectors, which is a1 a2 plus b1 b2 plus c1 c2 divided by magnitude of OP vector square root of a1 square plus b1 square plus c1 square square root of a2 square plus b2 square plus c2 square. Now, this is the formula. Instead of direction ratios, if you are given with the direction cosines, then you have the formula L1 L2 plus M1 M2 plus N1 N2, because if direction cosines are given, then their magnitude is always, it corresponds to the unit vector, magnitude is always 1 unit. So this denominator becomes 1, hence you are remained only with numerator. So when the lines are perpendicular, then if theta equal to 90 degree, so theta 90 means cos 90 is equal to 0. So you are remained with this becomes 0, a1 a2 plus b1 b2 plus c1 c2, which is equal to 0. The lines are parallel if the ratios are proportional. That is a1 by a2, direction ratios are proportional. a1 by a2 equal to b1 by b2 equal to c1 by c2, which all gives the constant value. Now, if you have the lines in vector form, that is r vector equal to a1 vector lambda into b vector, and r vector is equal to a2 vector plus mu into b2 vector, two vector lines are given in vector form, then as these two lines are here, b1 is parallel to the first line and b2 vector is parallel to the second line. So angle between these two lines is same as angle between the vectors b1 and b2. So you have to find out cos theta equal to magnitude of b1 dot b2 by magnitude of b1 into magnitude of b2 vector. So this is when the equations are given in vector form. Now let's solve few problems related to angle between two lines. Here two lines are given in Cartesian form. First you have to check that are the lines in the standard form. That is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Similarly, x minus x2 by a2, it is in the standard form. Therefore, these are a1, this is a1, b1, c1, and this is a2, b2, c2. We have the formula cos theta is a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square root of a2 square plus b2 square plus c2 square. Substitute all the values, 2 into 1 plus 5 into 8 plus 3 into 4 divided by square root of 2 square 4, 5 square 25, 3 square 9 into square root of a2 square plus b2 square plus c2 square. 1 square 1, 8 square 64 plus 4 square 60. So do the simplification. This is 54 root of 38 and it is 81, which is 9. So 9 ones 9, 6, 6 by root 38. So theta equal to cos inverse of 6 by root 38. This is the angle between those two lines. Now, next question, 12th question. Find the value of P so that the lines, these two lines are at right angles. So, right angles means cos 90 degrees 0. Therefore, the formula becomes A1 plus A2 plus B1 B2 plus C1 C2 equal to 0. Because cos of 90 is 0. So, whatever in the denominator, 0 into that value becomes 0. So, this is the condition. So, you have to equate this to 0 because already they had given they are at right angles. Find the values of P. Okay. So therefore, now you have to check are they in the standard form first. They are not in the standard form lines. X minus x1, that is the standard form. Y minus y1 by b, z minus z1 by c. So I am taking minus common, so it becomes x minus 1 by 3. Here I am taking 7 common, y minus 7 2 is 14 by 2p. Then this is as it is because it is already in the standard form. Here I am taking minus 7 outside, x minus 1 by 3p. Here it is as it is. Then take minus 1 common, z minus 6 by 5. Therefore, your a1 becomes minus 3, b1 is 2p by 7 because the coefficient of y minus y1 should be 1. So, this has to be in the denominator. So, it becomes minus 3 here. This is 2p by 7 and here it is 2. Then this is minus 3p by 7 and here it is 1 and minus 5. Substitute all those values here. A1, A2, minus 3, minus 3p by 7. B1, B2, 2p by 7 into 1. And C1, C2, 2 into minus 5. Do the simplification. 9p by 7 plus 2p by 7. 5 2 is minus 10. Bring it to the other side. So after taking LCM, 70, 9 plus 2, it is 11p. P equal to 70 by 11. Now let's solve few problems of exercise. So show that the three lines with the direction cosines are mutually perpendicular. Mutually perpendicular means first line is perpendicular to second, second is to third, third is to first. So you can name the direction cosines as L1, M1, N1, L2, M2, N2, and then L3, M3, and N3. So you have to prove L1, L2 plus M1, M2 plus N1, N2 equal to 0 because they are perpendicular. Then L2, L3 plus M2, M3 plus N2, N3 equal to 0. Then L3, L1 plus M3, M1 plus N3, N1 equal to 0. I will do 1. So that is 12 by 13 into 4 by 13. 48 by 13. First one I will do plus. This is 12 3s 13 square it is 169. Then plus 12 3s minus 36 by 169 plus then minus 4 3s minus 12 13 13s 169. So denominator is 169, numerator is, see, this is 48 minus 48 plus 48 cancel 0 by anything which is 0. Similarly, you do it for the remaining two lines. Hence, they are mutually perpendicular. Now, next second question is show that the line through the points 1 minus 1 2 3 4 minus 2 is perpendicular to the line through the points. We have to prove that the line through this point and another line through these 2 points are perpendicular. First you get the direction ratios of first line and get the direction ratios of second line. Direction ratios is easy because x2 minus x1, that's it. So a1 equal to x2 minus x1, 3 minus 1, 2. b1 equal to y2 minus y1, 4 minus of minus 1, that is 5. c1 equal to minus 2 minus 2 minus 4. Then A2 equal to 3 minus 0, 3. B2 equal to 5 minus 3, 2. C2 equal to 6 minus 2, that is 4. Okay. Now, we have to prove that they are perpendicular. So, A1, A2 plus B1, B2 plus C1, C2. If you get 0, then they are perpendicular. 3 2 is 6. 5 to the 10 minus 16. 16 minus 16 is equal to 0. Hence the lines are perpendicular. See, without drawing the lines, algebraically we are proving they are perpendicular. Now the third question is, show that the line through the points, these are the 2 points, is parallel to the line through these 2 points. First, let us find out the direction ratios of first line. A1 is x2 minus x1, 2 minus 4 minus 2. B1 is 3 minus 7 minus 4. C1 is 4 minus 8 minus 4. Then A2 is equal to 2, B2 is equal to 4, and C2 is equal to 4. That is 1 plus 1, 2, 2 plus 2, 4, 5 minus 1, 4. When you find out the ratio, that is A1 by A2, you will get minus 1, B1 by B2 minus 1, and C1 by C2 minus 1. Fourth question, find the equation of the line which passes through the point. So point is 1 comma 2 comma 3 and is parallel to the vector. So b vector equal to given 3I cap plus 2j cap minus 2k cap. So this is given in the question. Find the equation. You can find both the vector equation and Cartesian equation. So vector equation is a vector plus lambda into b vector. A vector is the position vector of the given point. When point is given, its position vector is given by this x component into I cap plus y component into j cap plus z component into k cap. I cap, so plus 2j cap plus 3k cap plus lambda into b cap, b vector is 3I cap plus 2j cap minus 2k cap. So this is the vector equation. Position vector of any point in the straight on the straight line is given by this. This is vector form. If you want Cartesian form, x minus x1 by a, b, c. These are the direction ratios along with the sign. These are the direction ratios of the vector b. As vector b is parallel to the line also have the same direction ratios. So 3 equal to y minus y1 is this point, 2 divided by b is 2, which is equal to z minus 3 divided by minus 2. So this is the Cartesian equation. Fifth question, find the equation of the line in vector and Cartesian form that passes through the point with the position vector. So directly they had given you here a vector 2I cap minus j cap plus a 4k cap, then and is in the direction b vector is equal to I cap plus 2j cap minus k cap. Instead of point, directly they have given you the position vector of the point. Same way, just substitute for vector form now. X minus x1 is this 2, y1 minus 1, z1 is 4. So x minus 2 by direction ratios are nothing but 1. Here y minus of minus plus 1 divided by 2 equal to z minus 4 divided by minus 1. So 1, 2, minus 1 are the direction ratios of B vector. As B vector is parallel to the line also has the direction ratios 1, 2, minus 1. Now, the given position vector of given point is 2I cap minus j cap plus 4k cap. So, position vector of the point is given. So, the coordinates of the point are 2, minus 1 and 4. So, accordingly, I have written here. Sixth question, find the Cartesian equation of the line which passes through the point minus 2, 4, minus 5 and parallel to the given line, parallel to the line given by. So that line is parallel to this line. So you know that any parallel lines will have the same direction ratio. So A equal to 3, B equal to 5, C equal to 6, because these are the direction ratios of a line which is parallel to our required line. So therefore, equation of the Cartesian equation, they are asking x minus x1, x plus 2 divided by 3 equal to y minus y1, y minus 4 divided by 5 equal to z minus of minus plus 5 divided by 6. The Cartesian equation of a line is, this is, write its vector form. So if you want to get the vector form of a line, which is in Cartesian form, so first write what is a vector, position vector of a point, x minus x1, so 5 cap. Now, this should be y minus y1, so minus of minus 4 you have to write, minus 4j cap, next plus 6k cap, plus because z minus z1, in the place of z1 you have 6. Then B vector equal to vector corresponding to the direction ratios. So 3i cap plus 7j cap plus 2k cap. Now you have to write the vector form as R vector equal to substitute A vector plus lambda into B vector. Now let's know about skew lines. Lines which are neither intersecting nor parallel are called as skew lines. For example, if you consider a cube, now the line joining these two corner points and this line, these two are skew lines because they never intersect each other and they are never parallel also. Though this portion looks like parallel, but as you proceed, that goes non-parallel. So these lines which are neither intersecting, they also don't intersect anyway, and nor parallel, which are called as skew lines. These are non-coplanar lines, means they can't be in the same plane. These two lines should be in different planes. So that's why we call them as non-coplanar lines. Because in any plane, if you consider two lines, then those two lines are either parallel or intersecting. Here, these are neither parallel nor intersecting, hence these are non-coplanar lines. Now let's see how to find out the shortest distance between two skew lines. Now let's see how to find shortest distance between two skew lines. So what I'll do is take two skew lines L1 and L2, means they can't be in the same plane. Here I am just drawing a representative diagram because it is a plane of the screen. So these two lines in a plane either intersecting or parallel. Here it looks like they are intersecting, but you have to assume that these two are skew lines. They means they are in different planes. Now I have to get the shortest distance between these two skew lines. See, distance between two lines is nothing, but you have to draw a line segment between the two lines. Means a point on the one line, and you have to consider another point on the another line. Then join those 2 points. You can join it different places, but you will get the shortest distance when you join those 2 points in such a way that the line segment joining those 2 points is perpendicular to both the line. That particular line segment gives you the shortest distance between the two skew lines. You can draw here, you can draw here, anywhere you can draw a line which joins the 2 points on the two lines. But we want the shortest, that gives you the distance between two skew lines. But we want the shortest, therefore we want to find out a line segment which is perpendicular to the both lines. So I have considered here two lines L1 and L2, two skew lines which are represented by the equation R vector is A1 vector plus lambda B1 vector, and R vector equal to A2 vector plus mu into B2 vector. So B1 vector gives you the direction of first line, B2 vector gives you the direction of second line. Now, A1 vector is a position vector of a point on the first line. So, I will consider a point S on the first line with the position vector A1 vector, and a point T on the second line with the position vector A2 vector. So, position vector means you have to draw actually the coordinate axis also. Then distance of the point S from the origin and distance of the point T from the origin gives you the position vectors of the point S and T respectively. They are nothing but A1 vector and A2 vector. Now you have to join 2 points which are on the two lines, then in such a way that that line is perpendicular to both L1 and L2. Now this is the line segment which gives you the shortest distance between the two lines L1 and L2. Actually it is perpendicular to the screen. Here it looks like just perpendicular to L1 and L2. It will be in the some other plane, like it is perpendicular to both L1 and L2. So it is perpendicular to the screen. So in this way, like forward to the screen. That way it will get projected. So you will get a vector PQ vector joining the points P and Q. Now you have taken 2 points on the line S and T. So join those 2 points, you will get ST vector. Now your PQ vector is perpendicular to both L1 and L2 because PQ vector is the shortest distance vector, hence it is perpendicular to both L1 and L2. But your B1 vector and B2 vector are parallel to L1 and L2 respectively. They are in the same direction. Therefore, your PQ vector is perpendicular to both B1 vector as well as B2 vector. Okay. So now length of this PQ vector gives you the shortest distance between L1 and L2. I will name that shortest distance as D. Okay. Now, as you have two vectors b1 and b2 vector, where will be the cross product of these two vectors? This you have studied in vectors. When you have two vectors b1 vector and b2 vector, their cross product will be perpendicular to both b1 vector and b2 vector. Therefore, b1 cross b2 vector is perpendicular to both b1 vector and b2 vector. But we already have now PQ vector is perpendicular to B1 vector and B2 vector, both B1 vector and here B2 vector from this. Whereas B1 vector also cross B2 vector is also perpendicular to both B1 and B2 vector. So eventually what happens? PQ vector and B1 vector cross B2 vector is perpendicular. These two vectors are in the same direction. So this gives you B1 vector and B1 vector cross B2 vector is perpendicular to both L1 and L2 as it is perpendicular to both B1 and B2. Therefore, it should be perpendicular to both L1 and L2 because L1 L2 are in the same direction as that of B1 and B2 vector. Therefore, eventually PQ vector and B1 cross B2 vector both are in the same direction because this is also perpendicular to L1 and L2. PQ vector is also perpendicular to L1 and L2. Both are perpendicular to L1 and L2 means they should be in the same direction. Now I want unit vector along B1 vector cross B2 vector. I have to find out the unit vector along B1 vector cross B2 vector, which is given by n cap is equal to B1 vector cross B2 vector divided by magnitude of B1 vector cross B2 vector. You know that unit vector along any vector is A vector divided by magnitude of A vector. Same thing I have written. Now, as this is a unit vector along B1 vector cross B2 vector, this is also a unit vector along PQ vector because they are in the same direction. Therefore, now I got magnitude of PQ vector as D. I named magnitude of PQ vector as D. Direction of PQ vector is same as the direction of B1 cross B2. That is unit vector along B1 cross B2 n cap. So I can write PQ vector as magnitude into direction D into n cap. I got PQ vector expression. Now what you should do is you have to find out, now you have to find an expression for this D, distance between, shortest distance between two skew lines. So what I'll do is you have to project this ST vector onto PQ vector. I think you know the concept of projection of one vector on another vector. So if you have two vector, projecting B vector on A vector is given by dropping a perpendicular from B vector onto A vector. Then from the initial point to the foot of the perpendicular, whatever distance you will get here, this is called as projection of B vector on A vector. And OM vector is the projection vector. The length of OM vector is called as its projection, magnitude of that projection. Now I am going to project ST vector onto PQ vector. So you bring that ST vector here. Okay, make their initial point common. Join the initial point of ST vector with the initial point of PQ vector. S and P will coincide. Now you will get ST vector here. You have to drop one perpendicular from point T to the point Q. Now, no need to draw perpendicular because this is already perpendicular. We have seen that this PQ vector is perpendicular to L2. Therefore, this line acts as perpendicular to PQ. So, therefore, the projection of ST vector onto PQ vector is nothing but magnitude of PQ vector, which is nothing but the shortest distance between two lines. So projection of ST vector on PQ vector is equal to magnitude of PQ vector. Here we got OM, no? Same way here, magnitude of PQ vector, which is nothing but D. So D is equal to, you have a formula. What is the projection of A vector on B vector? Which is A vector dot B vector by magnitude of B vector. So ST vector dot PQ vector by magnitude of PQ vector. Now ST vector can written as OT vector minus OS vector. Position vector of point T, which is A2, minus position vector of point S, which is A1, dot this PQ vector is D into N cap divided by magnitude of PQ vector is D. D cancels. Then you will get the expression as A2 minus A1 dot N cap substitute B1 vector cross B2 vector by magnitude of B1 vector cross B2 vector. This much only. This gives you the shortest distance between two skew lines. Now, if you want to find out the expression for distance between two skew lines in terms of Cartesian form, when the lines are also given in Cartesian equations, then see the formula. We have to get to the vectors one by one, b1, b2, a2, a1, then b1 cross b2, a2 minus a1. So b1 is given by the direction of first line, a1 I cap plus b1 j cap plus c1 k cap. B2 is given by the direction ratios of second line, A2 I cap plus B2 j cap plus A2 k cap. A1 vector is the position vector of first point, x1 I cap plus y1 j cap plus z1 k cap. A2 vector is the position vector of second line, x2 I cap plus y2 j cap plus z2 k cap. So A2 minus A1 is given by x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So B1 vector cross B2 vector is given by the determinant of I cap, J cap, K cap, components of B1, A1, B1, C1, components of B2, A2, B2, C2. Evaluate this, you will get B1, C2 minus B2, C1. Similarly, the next two values. Substitute all these here. So this is nothing but dot product with this cross product, which is scalar triple product. That is given by the determinant of components of A2 minus A1, then components of B1 and components of B2. So A2 minus A1 components are x2 minus x1, y2 minus y1, z2 minus z1. Determinant, first row is that. Second row, components of B1, A1, B1, C1. Third row, components of B2, A2, B2, C2. So whole divided by square root of b1 c2 minus b2 c1 whole square. That is because the magnitude of b1 vector cross b2 vector, which is here, its magnitude square root of this value square plus this value square plus last value square. So this gives you the expression for distance between two skew lines in Cartesian form. Now here there are problems related to finding shortest distance between the two lines. See 14th problem. So it is given there, two lines, pair of lines given. You have to find out the shortest distance between these two lines. You have to check first, are these skew lines or are these parallel lines? So they are not parallel because the direction of first line and direction of second line are different. So this B vector, you have to check this vector, lambda into some vector. If that vector is same, then the direction is same. Then the lines will become parallel. Here two different vectors are given. So the two lines are in different direction. They can't be parallel. So you have to use the formula of distance between two skew lines. So we have the formula D equal to A2 vector minus A1 vector dot B1 vector cross B2 vector by magnitude of B1 vector cross B2 vector. So let us identify which is A1 vector. This is your A2 vector. This is B1 vector and B2 vector. So I have written all this here. Now I want B1 cross B2. I hope you know how to find the cross product. Determinant I cap, J cap, K cap. Components of B1 vector 1 minus 1, 1 and components of B2 vector 2, 1, 2. So simplify this determinant I cap into minus 2 minus 1 minus j cap into this cancels 2 minus 2 plus k cap into delete first row third column 1 plus 2. So this gives you minus 3 I cap. This is 0 plus 3k cap. This is your b1 vector cross b2 vector. Now here only you find out what is a2 vector minus a1 vector. So a2 vector minus a1 vector is 2 I cap minus I cap, which gives you I cap, minus j cap minus 2j cap minus 3j cap minus k cap minus k cap minus 2k cap. Substitute here. It is the dot product. Dot product of two vectors, you know, a1 a2 plus b1 b2 plus c1 c2. You have to multiply the corresponding I cap, j cap, k cap components and add all them together. So here a2 minus a1 and b1 cross b2. So minus 3 and component of I cap is 1. So 1 into minus 3. Component of j cap is 0 and component of j cap minus 3. 0 into minus 3 plus component of k cap is 3 into minus 2 divided by magnitude of b1 cross b2, that is 3 square 9 plus 9. So which gives you minus 3 minus 6, that is minus 9 divided by it is 9 twos, so 3 root 2. 3 ones, 3 threes. So that is modulus because distance is always positive. So you will get the answer as 3 by root 2. Now in the second problem, that is 15th problem, find the shortest distance between the lines. Here also, the lines are given in Cartesian form. It was in the vector form, now it is in the Cartesian form. So what I'll do is I'll make use of the same formula, vector formula only, because it is easier if you use the vector formula to simplify. Otherwise, you have to remember one more Cartesian formula also, that determinant of x2 minus x1 divided by square root of b1 c2 minus b2 c1 whole square. So it is kind of lengthy formula. Instead of that, what I'll do is I will use same vector formula. I'll convert the given Cartesian equation into vector form. So first you write what is x1, y1, z1. So x minus x1. So it is x minus of minus 1. So x1 is minus 1. Y1 is minus 1. Z1 is minus 1. Similarly for the second line, x2 3, y2 5, z2 is 7 because it is already in x minus x1 form. Next, a1, b1, c1, 7 minus 6, 1. a2, b2, c2, that is 1 minus 2, 1. So now we have the formula, that is d equal to a2 minus a1 vector dot b1 cross b2 divided by magnitude of b1 cross b2. This is the formula. So find out first what is a2 minus a1. This is a2 vector minus a1 vector is not this. This is b. This is vector b1 and this gives you components of vector b2. Now this a2 minus a1 we want. So you have to subtract these components, x2 minus x1, y2 minus 1. So 3 minus of minus 4ik, 5 plus 1 6jk, 7 minus of minus 8kk. Then we want b1 cross b2. So you know I cap, j cap, k cap. Components of b1 7 minus 6 1. Components of b2 1 minus 2 1. So evaluate this determinant, minus 6 plus 2 minus 4. Delete first row second column, minus j cap into 7 minus 1 6 plus k cap into minus 14 plus 6. That gives you minus 8. Now make use of the same formula, substitute all the values here. So this vector and this vector corresponding combo, 4 into minus 4 plus 6 into minus 6 plus 8 into minus 8 divided by the magnitude of b1 cross b2. So we got square root of 16, 6 square is 36 plus 8 square is 64. So that gives you, do the simplification, minus 16 minus 36 minus 64 by square root of 116. So you have modulus here, so that makes the negative value as positive because distance is positive. 116 by root 116, that is square root of 116. This is how we find the shortest distance between two skew lines using one particular formula. I have used the vector form of that formula. Now let's see how to find distance between two parallel lines. I have considered two parallel lines. These are planar lines in the same plane, L1 and L2, given by the equation R vector is A1 vector plus lambda B vector. R vector is A2 vector plus mu into B vector. Here this vector is same, so v1 and v2 is equal to b vector because they are parallel, therefore they will be in the same direction. One just b vector represents the direction of both L1 and L2. So now I have to find out the distance between shortest distance itself. No need to specify the shortest distance because whenever you draw a line joining these 2 points perpendicular between the points L1 and L2, that itself gives you the shortest distance between the two lines. Now I have dropped a perpendicular from L2 to L1. So I'll get a PT vector. So T is the point from where I have dropped perpendicular. P is the foot of the perpendicular here. So PT vector you will get. Take any point on the first line S and any point, same point I will take T on the line L2. Now project position vector of point S is A1 vector and position vector of point T is A2 vector. Now you have to take theta be the angle between ST vector and line L1, which in turn gives you that theta is the angle between ST vector and B vector because L1 is parallel to B vector. So you have theta as the angle between ST vector and L1, that is nothing but B vector. Now from this triangle SPT, I am going to find out sine theta because I want the magnitude of PT vector, that is PT. That PT comes in sine theta. Let me use sine theta equal to opposite by hypotenuse is ST. So PT, I want this value of PT, which is ST into sine theta. PT is the, you can name it as D, distance between two parallel lines. Now we have sine theta is equal to modulus of ST vector cross B vector by magnitude of ST vector into magnitude of B vector. That is cross product of, because I know the angle between the two vectors ST vector and B vector. So I will make use of a cross product because in the cross product you will get sine theta. So ST vector cross B vector equal to modulus of ST vector modulus of B vector into sine theta into n cap. But when you take modulus on both sides, magnitude of n cap becomes 1 as it is unit vector. Then you can evaluate what is sine theta, which is given by this formula. Now therefore shortest distance D equal to PT. So ST into, I got an expression for sine theta now in terms of cross product here. The divided by substitute here, ST cancels. Then ST vector is given by OT vector minus OS vector, position vector of second point minus position vector of first point, which is A2 vector minus A1 vector cross B vector divided by this, anyway cancel this value, magnitude of B vector. So that's it. This gives you the distance between two parallel lines. Derivation is simpler compared to the distance between two skew lines. Now here is the problem. Find the distance between the lines L1 and L2 given by two equations are given. Now when you look at the equation of the lines, B1 and B2 vectors both are same. That means these two lines are in the same direction, which indicates the lines are parallel. Hence, you have to write the formula to find the distance between two parallel lines, which is given by D equal to magnitude of A2 vector minus A1 vector cross B vector by magnitude of B vector. So, first let us identify A1 vector. This is A2 vector. This is your B vector. You just have B vector. So now find out A2 vector minus A1 vector, which is 3i cap minus I cap 2i cap. Then 3j cap minus 2j cap plus j cap. This 3j cap minus 2j cap plus j cap minus 5k cap plus 4k cap minus k cap. That is A2 minus A1 vector. B vector is 2i cap plus 3j cap plus 6k cap. Now we want the cross product of these two, which is A2 vector minus A1 vector cross B vector, which is equal to the determinant of I cap, j cap, k cap, components of A2 vector minus A1 vector, that is 2, 1 minus 1, components of B vector 2, 3, 6. Now evaluate this determinant. I cap is 6 plus 3 9 minus j cap, delete first row second column, 12 plus 2 14. K cap is 6 minus 2, that is 4. Now let us find out magnitude of this cross product. 9 square 81 plus 14 square 196 plus 16, which is square root of 293. Substitute in this formula. We want magnitude of B vector, which is square root of 4 plus 9 plus 36, which is 49, that is 7. So answer is square root of 293 divided by 7. This is the distance between two parallel lines. I hope you understood all the concepts. Thank you for watching.